Elixir has a lot of great features, like some concurrency support with processes. It's concurrency oriented. It has fault tolerance with stuff like supervision trees. It has the great OTP, and all of these are great features, but they're mostly used at runtime, right? Mostly used at runtime. So, but I think one of the greatest Elixir features is its compiler, right? So I don't like the word metaprogramming because I think it's needlessly complicated, but all the metaprogramming in Elixir comes from the Elixir compiler, right? So it's a great tool, and Gettext, which is what we're going to talk about here, is very, very simple at runtime. Most of the work we do in Gettext is done at compile time. So in this talk, I hope to introduce Gettext, but also to show how powerful the Elixir compiler is and how much you can get done with it. So this talk, for once, it has no concurrency involved. It has no processes, no supervision, no let it crash. It's the last talk of the conference, so it's just keep it light. So it's agents free, it's supervisors free, it's let it crash free. By the way, Gettext never crashes. There's no bugs, so you don't have to worry about that. I'm sure there are bugs, maybe. So my name is Andrea Leopardi. Watch it on GitHub and Twitter. I come from Italy. I don't know if you can see it from the picture, but this is the most interesting thing I can do is, like, if I squeeze my face very hard, I'm able to sit on very high invisible chairs, like that one. I would gladly do it here, but it's dangerous, so I can't. So I work at a company called Chorus 51 based in Italy, and I'm here thanks to them, so thank you. And so today we're going to talk about Gettext. So what is Gettext? It's an internationalization and localization framework. So basically, it's used to translate applications into different languages, mostly. So let's clarify some of these terms. The first one means internationalization, and it means predisposing an application for supporting multiple cultures, regions, and languages, or locales, right? And the second one means localization, which is actually adapting an application to a specific culture or region or language, which means translating to a specific locale. And the last one means boring, because internalization is very, very boring matter, but it needs to be done, right? So usually, so most people here come from Ruby, so this should look very familiar. This is how Rails and other tools do internationalization, which is by having big YAML files with all the translations in them, each one file per locale, and using keys to find the translation for a given string, right? And this is very confusing, in my opinion, and in a lot of other people's opinion. But basically, what this does is it hurts the programmer, because when the programmer sees translate greetings.informal, it has no idea what greetings.informal is. I mean, it has an idea, but it doesn't know for sure what it is, right? It's very general, and it gives you very little context, right? And so to find what it means, you have to dig through YAML files. You have to find the YAML file for the base language. You have to find the key, and then you can read the actual string that was going to be put there, right? And it hurts translators as well, because translators now have to, for translating, they have to work with two files side by side. They have to work with the base language file and the specific file for the locale they're translating to. And this is uncomfortable. Also, they have to, if they want to to know the context where a string is, to maybe give a better translation, they have to retrieve the translation key in the code base, and usually it's not an easy process, because you have no references to where a translation comes from in the code base. So it's pretty messy system. I know. It's nobody thinks about translators because we're programmers, but we can know just so many languages ourselves, right? So at some point, if you need to internationalize your application, you will need to talk to a translator. I know it's bad, but you have to do it. So Gettext approach is much simpler. So basically, the core idea is English strings are keys for themselves, right? So an English string is the key for all other translation in all other languages. And the nice thing about this is when you write a translation in your application, it's going to look like the string that is going to be translated, right? So that is, you have the string hello, and you see that is the English string hello, and it's easy to see what it means, right? Because it's the actual string. And you store translations in a separate file, in separate files which are PO files, which is a Gettext specific format. And translation in PO files are very readable. They have a message ID, which is, again, the English string, so it's very easy to see what it means. And they have a message string, which is the translation of the string, right? You have a locale for each PO file, like YAM files. You have the message ID, again, which is the English string you're going to translate. And you have the translation, like the translation for the given locale. And you have also references to where those strings come from in the code base, right? So it's very easy to track where you use those translations in the code base for more context if you need more context to translate. So it's great because developers see plain strings, right? They don't have to look up YAML files to see what they're working with. And so no context is required. And translators see plain strings as well when they don't ever have to deal with keys like in Rails, for example. And so they don't need to deal with YAML files, which are like more programmer friendly than translator friendly probably. And it's also easy to translate PO files because you have you just take a PO file, an empty PO file, which has no translation, only has the message IDs, so the English strings you have to translate, and you basically just fill in the translations by looking at the English translation, right? So PO files are very simple. They have a translator-friendly syntax. They're easy to read and easy to parse, and they're not thought for programmers. They're thought for everyone. And there are a lot of, they're not language specific, so there are a lot of Gettext bindings for a lot of languages. Python, PHP, and C use Gettext. I think as Python has its default internationalization solution, but so they're not language specific. And there are a lot of tools that know how to deal with PO files. One of them is Poedit, which is a great tool. It allows translators. It's easy to use for translators, right? And it has nice features like automatic translations. I don't know if you can see that, but you basically just have it automatically tries to translate English strings into the locale you set up. So it has a lot of nice features for translators. And so what we did is build like a binding for Elixir for Gettext, right? So José a few months ago came to me and said, "Do you want to build this?" I said, "I'm not stupid. Yes, I will." So I worked on it alongside José for the last few months. We released the first version a couple of weeks ago. So it's available on X, and you can use it today. And I feel like Steve Jobs presenting a feature. So it's available. You can use it today. Yeah. So let's talk about the most interesting feature of Gettext, and we'll pick at the implementation of those features. And we're going to see a lot of compile time stuff that we took advantage of to make Gettext very simple at runtime and very fast at runtime as well. So what we're going to look at, how Gettext reads translations from PO files, at how it extracts translation from source. We're going to talk a lot more about this later. How it interpolates, it does string interpolation in translations, and how it does pluralization. So first one, how it reads translations from PO files. So this is the easiest one. You just, basically, you need to convert PO files and the translations you have in PO files to Elixir data, right? And so we do a very common thing. You use a very common pattern that is used pretty often in Elixir, which is we generate function clauses dynamically at compile time, one for each translation, right? So the code, the simplified code looks something like this. So we have a Gettext model, and what we do is we read the PO files at compile time. So module attributes are evaluated at compile time. So we read files at compile time, and we get something like a list of message ID, message strings, tuples. Then we go over the list, and we define a function clause for each translation, which basically maps message ID to message string, right? So ID, translation ID to actual translation. And this is maybe analogous to like something like a map lookup. Probably is how they do it in other languages, but it's optimized by the Erlang virtual machine, and so it's fast, and it's it reduces the complexity of the runtime And so this, as I said, this is a very common pattern. So this is the code we're looking at. This could be in principle, this is the same code and this is the code that Elixir uses to lowercase and uppercase and deal with Unicode code points and Unicode stuff, right? So in principle, it's the same. You read code points from a file and you generate dynamically function clauses, right? Roughly, it looks like this. So it's very fast to runtime. And the thing I prefer is that, well, you move logic away from runtime, right? So you have a lot of logic at compile time, but that all goes away at runtime, right? You don't pay for what you do at compile time, and you only have the result of that at runtime, right? The code you run is only the result of that. So bottom line, the compiler is your friend here. It helps you a lot, and it simplifies runtime a lot. So another feature Gettext says is extracting translations from source. So basically, the idea behind Gettext is to make life easier for both translators and programmers, right? And one way to make life easier for programmers is, letting them put off translations as much as possible. So in stuff like Rails, when you have to write a string, for example, in a template, you can decide either to write it now as a constant, as a string literal, and then going over it again and replacing it like with a T method, which translate method that takes a string key, and so you move the string literal into a YAML file, or you write it directly into that, and you have to open like a YAML file every time you have to write a literal string, right? So what Gettext, the idea behind Gettext is you always wrap strings that you're planning on translating inside Gettext calls to the Gettext function, right? To a Gettext function. And and that function by default returns the string you pass it to it, right? So it's like transparent. And when you want to start internationalizing your application, you extract translations from the code base, right? So extracting translations means you go over obviously the code does it for you, but it goes over the whole code base and extracts translations into POT files, which are like PO files. POT stands for PO template, and are like PO files, but they don't have the message string filled in, right? So they're not locale specific. They're just generic template that translators have to fill up when they're translating. So most of the Gettext tooling for Python or C, for example, does this by basically scanning the source code and looking for calls to Gettext function, which are usually alias to underscore. But the idea is they look for Gettext functions by parsing the code, and they extract. So and that's how they get the information about the strings that will have to be translated and how where they are, for example, in what file, what line they are, and so on. So this is usually done with an external program, obviously, because there has to be an external program that parses the code and looks through the code and extracts translation. And we do it in a much nicer way, I think, which is macros, right? And I always thought of macros as a tool to like manipulate the AST and return a new AST or something similar. But you can use functions. You can use macros just as functions that also do stuff at compile time, right? You could rewrite every function you have as a macro that does nothing at compile time and just returns the quoted the abstract syntax tree for what the function would have done, right? So this is a very nice idea. So basically, we don't do anything special with the AST. We just call a function in the quoted AST we return. But we do extract translations at compile time, right? So what you do to extract translations is you call mix gettext.extract, and this first recompiles all the project. So it recompiles all the files in your project. So all macros are recompiled, and all the code in macros is executed, right? And this is what the Getext macro, which is so what it looks like roughly. And basically, this is what I'm talking about, right? You have a quote do and part that you return, which is the AST that's going to be executed at runtime, and then you have everything before that is executed only at compile time, right? And it goes away at runtime. So what we do is we extract translations exactly there. So that call to extract basically registers the translation that later will be extracted into a POT file. The only limitation is that the message ID has to be a string at compile time, because we need it, well, because we're using this feeder at compile time. So it has to be something that expands to a string, like a module attribute, or just a string literal. But Getext supports also dynamic translations, but it doesn't support extracting those translations, obviously, because you don't know what they're going to be until runtime, right? And so basically extracts, what it does is it pushes to an agent. So I know I said no processes, but this is the only one. And so the translation is pushed to an agent that runs during compilation, right? This for me, it's amazing because you're using OTP during compilation, right? So you have all the abstractions, all the power processes, supervisors, agents, and all the stuff like that also during compile time, because you're using Elixir to compile Elixir, right? So this is a very powerful concept, in my opinion. And so basically, we push to an agent, we push translation to an agent, and we have all the information we need, because we have the caller of the macro, so we have the file where the macro is used in, the line number, and so we have all the context we need right in the macro. And this is, obviously, this is an oversimplification of the function, but given the knowledge that Gettext supports also domains, which are a way to separate translations, and it also supports a dGettext function, which is exactly like Gettext, but takes also a domain to find the translation. This is the actual implementation of this function. So it's of this macro, sorry. So it's very, very short, very, very concise. And you can probably recognize the patterns I described here, oversimplified here. Basically, we just expand the string, expand the message ID to see if it's string at compile time, we raise if it's not. And then if you're extracting, so if you call mix gettext.extract, we push the translation to an agent, and then we just return a quoted code, which is just a call to a function that basically just calls one of the functions we generated at compile time. So it just does some dynamic niceties around that. But so the nice thing about all this is that this has zero runtime cost, right? So all this code we're using to extract translations has absolutely no runtime cost, because it's all done during compile time, and then it goes away because it doesn't affect the quoted AST that the macro, the Gettext macro that showed returns, right? So this is amazing. And the compiler is a friend again, because we're just simplifying runtime a lot, but we're doing a lot at compile time at the same time. So another thing we do, we support is interpolating translations. So you can't interpolate translation strings with like pound curly bracket syntax in Elixir, because we need keys to be constants. And we need them at compile time, so we can't interpolate them. But we do support something that looks like this. So we have a % curly bracket syntax for interpolation, and basically, and we pass some bindings to it. And basically, what this compiles to is just a case statement, but the case statement is not important because it's just used to check that all the bindings are there and to bind them to variable. But it boils down to is like a a list of applications of the string concatenation operator. So it's very fast as well, and this is all done at compile time. So this is what the code looks like after it's compiled. The last thing we're going to look at is pluralization support. So this is just a very simple feature, but basically you can also translate strings that have a plural form. So for example, here we have the singular form. When you use English, you only have 2 plural forms, which are one when you have one element, and then another one when you have 0 or more than one elements, right? So we have one attendant, which is the singular form, and count attendants, which is the plural form. And in the PO file, this looks like this. So you have a message ID and a message ID plural. And this message ID and message ID plural couple is the ID of the translation. And then you have translations for each plural form. 0 and 1 are just identifiers for saying singular and plural, right? And in other languages, you have more than 2 plural forms. Arabic has actually 6 plural forms. And so, yeah, want to give a round of applause to Arabic for? I didn't think so. So basically, you can customize. The idea is that you can customize how pluralization. Gettext comes with its own pluralization support for a lot of languages. But if you invent a new language, or if you want to do like Star Trek stuff, you can define your own pluralizer module and use that if you want. So let's talk about the workflow of Gettext. So how do you actually, from start to end, use Gettext in an application? So what you do is, the first thing you do is you just define a Gettext module. We need to do that because we need to generate all those dynamic function clauses I talked about earlier. So we just define a Gettext module, and when it gets compiled, we read the PO files and compile them to function clauses. Then we just call, write source code. We wrap all the strings that we're planning on translating into the Gettext or Gettext macro, and we go happily coding until we want to actually internationalize the application. And once we do, we need to extract translations. So we use the mix Gettexturedistract task I was talking about earlier. And basically, this will extract translation to POT files, which again are just like PO files, but are templates, so they don't have the message strings, the translations filled in. And they're locale agnostic because they're just templates, just like templates. And then so this is what a POT file could look like. And so translations, in this phase, this is the extraction phase. So this is the thing we're talking about with the macro that extracts translations. And we have where the translation comes from. We have a source reference in the code base. And then, so once we have all these POT files, we hand the application to translators that are going to translate it. And what they will do is they will call the mix gettext.merge task. And gettext.merge is used both to create actual PO files from POT files, as well as update PO files from updated POT files. So I'm going to talk about this in a minute. But basically, you call gettext.merge with a directory full of POT files and with a locale. And what happens is, the first time you run it just creates a PO file for each POT file in that locale. And they're all still empty, right? Because Gettext doesn't know the translation for the translation for the strings you want to translate that are in the POT file, and so the translator goes in and fills the translations in the PO file. Then you basically, when you update the source code, you just call mix Gettext.extract again, and the POT files are updated with the new translations, and Gettext.merge will update the PO files based on the new POT files. So it will discard all translations that you're not using anymore. It will just add new translations without a translated string, because it still needs to be translated. And for matching translations, it will just use the translation that it finds in the PO file, right? So, for example, if we moved the call to get text hello world around in the code, for example, in another file, this would reflect in maybe updating just the source reference of the file without changing the translation and using the actual translation string that we had before. And we also support fuzzy matching in this case. So for example, say we had a hello word without an exclamation mark in the PO file, and we add an exclamation mark in the source code. Then we run mix Gettexturedistract, and we get the translation with the exclamation mark in a POT file. When we're going to merge it, we're gonna see that those are very, very similar, and we're gonna keep the translation that was already there, so the translation without an exclamation mark, and we're gonna just mark it as fuzzy so that translators can review that. By the way, we're using gyro distance that José talked about this morning to do this. So this needs 1.1 to work. Gettext needs Elixir 1.1 to work, just as a heads up. And basically, you do that again, right? So you continue to write source code, you extract new translations, and you update POT files. Then you run Gettexturedistract merge and update PO files with the new translations in the POT files. So this is pretty much it. You can use Gettext into existing application right now. It's on X. We released a couple of versions already. It's pretty feature complete. So it would be great if you tried it out and let us know of any comments or any bugs you find. And this is it.